Welcome to today's Explainer. We are setting the stage for a real head-to-head matchup between two absolute heavyweight industrial structural adhesives from 3M. We're going to be dissecting their safety data and spec sheets to see exactly what powers their performance. Specifically, we'll be comparing their fundamental chemical compositions, their curing mechanisms, diving deep into their technical specs, and looking closely at their water resistance to see how they stack up against strict product waterproofing standards. So let me ask you this. Are you losing assembly line speed to slow curing adhesives? Or, maybe worse, are you struggling with joint failures when your products actually get out there and face extreme real-world environments? If you're looking to optimize both your manufacturing speed and your structural durability, well, this analysis is exactly what you need. Let's go ahead and meet our contenders. In the black cartridge, we've got the 3M DP420NS Epoxy. This is your heavy-duty, highly durable solution. And in the gray container, we have the 3M DP8507NS Acrylic, which is really known for its speed and resilience. Now, both of these are absolute manufacturing giants, but they are built for entirely different missions.
Round 1. Chemical composition.
Pulling the chemical breakdown directly from 3M's own safety data sheets reveals their core differences. The DP420NS is built on a pure epoxy resin foundation, specifically CAS 250-68386 for those keeping track, and that is the absolute bedrock for massive static bonding strength. Conversely, the DP8507NS acrylic utilizes a methyl methacrylate base, and that's blended with a heavy dose of dibenzoate propanol. This fundamental chemical divide is exactly what dictates all the speed and strength differences we're about to see. Round 2. Curing mechanisms. Okay, so the acrylic adhesive offers just blazing speed. You get a really tight 7 minutes of open time to work, but here's the kicker. It hits handling strength in just 15 minutes. In the real world, that means you can move a bonded part down the assembly line literally before your morning coffee gets cold. And full structural strength, that follows in just 25 minutes. Now, contrast that sprint with the slow, steady curing profile of the DP420NS epoxy. It gives you a very comfortable 20 minutes of open time for those complex alignments. However, reaching handling strength takes a full 2.5 hours. If you bond it in the morning, you're waiting until after lunch to safely move it. It basically trades speed for ultimate solidity. Round 3. Technical parameters. So does that 2.5-hour wait actually pay off? Oh, absolutely it does. If your application demands extreme load-bearing, the epoxy is a total monster. It boasts a massive tensile strength of 39.6 megapascals. To put that into perspective, you're talking about thousands of pounds of force per square inch. It also has an overlap shear strength on cold-rolled steel of 23.7 megapascals. These are numbers for creating near unbreakable static bonds. Furthermore, the epoxy delivers an exceptional bell peel strength of 11.4 newtons per millimeter. What that actually means for us is that it has an incredibly high resistance to tearing or peeling forces. Basically, once it grabs on, it stays locked. So how exactly does the acrylic compete with that? Well, it balances its rapid cure with a toughened formulation at a 10:1 mix ratio. But honestly, the most brilliant engineering detail here, it incorporates microscopic ceramic particles. These little guys act like tiny spacers, automatically controlling the perfect bond line thickness when you press two surfaces together. It's a highly refined design, for sure. Round 4. Water and environmental resistance. Now, this is where the acrylic truly shines, especially for products that need to meet strict waterproofing standards. After 500 solid hours submerged in pure water, its shear strength holds strong at 18.9 megapascals. But incredibly, when it's soaked in a highly corrosive 5% saltwater solution, its strength actually measures slightly higher at 19.2 megapascals. Its water and salt resistance is just extraordinary for waterproof applications. And that resilience, it extends right into harsh chemicals too. Even after 500 hours completely submerged in gasoline or diesel fuel, the DP8507NS acrylic maintains an impressive shear strength of over 17 megapascals. It barely degrades at all in heavy fuel solvents. But, an objective analysis means we have to point out limitations. The Achilles heel of this acrylic is the extreme combination of high heat and high humidity. When it's baked at 85 degrees Celsius alongside 85% relative humidity, its strength plummets down to 4.3 megapascals. So constant tropical-grade heat applications, those are going to require some careful consideration. Conversely, the DP420NS epoxy stands out with highly stable overall environmental resistance. It completely avoids those drastic drops under combined heat and humidity. Plus, it carries the prestigious UL94HB certification, which proves its material safety and flame retardancy, a really crucial standard if you're working in electronics and appliances. So what does this all mean? Well, that concludes our breakdown, and it ultimately comes down to a calculated trade-off. Do you choose the blazing speed, chemical survival, and water resistance of the acrylic to accelerate your line and meet strict waterproofing standards? Or do you rely on the massive physical strength, stability, and flame-retardant safety of the epoxy? The right choice depends entirely on what you are building next. So, which adhesive is going to build your next product?